All right, we're back. Second part of 1.12 notes. What happens if we get 3 or more linear inequalities? Well, first of all, don't panic. That's your first step. Second step, let's get y by itself so that graphing this thing isn't the issue. So this one's already, we should know what that is, right? I mean, greater than or equal to -1. We saw that. We saw that last lesson. It was a vertical line. So here's my y-axis, here's x. At -1, and then the shading was all to the right of that because it's greater than or equal to. It's the one case where we can't do the above-below analysis. So, okay, 3 colors. Start with this one. So to the right of it. Our next one. Good maintenance work on getting y by itself. Subtract the 3x from both sides. -3x plus 12. Divide by 4, divide by 4, divide by 4. By the way, I didn't make any note of this, but when you divide by a negative on the bottom, you flip the sign. But if the negative's on top, and you're still just dividing by a +4, don't flip the sign. Like in this case, keep it as is. So start at 3. This is going to get a little wonky because now we're going to put holes in this shaded region. So start at 3. Go down 3, right 4. Or up 1, 2, 3, left 1, 2, 3, 4. Bold still. All right. This means shade below. Let's go with yellow. That'd be everything below this line. All right, you get the idea. And of course, this is yellow too. But hopefully you guys are starting to get the idea that, okay, so our shared shaded region is already, between 3 of these, is limited to just this sector right here. This sector right here is going to contain our final answer. It's just the question is, how limited is that space going to be? Because what's this line going to do? Well, we're about to see. So got the first one, check. Second one, check. Third one, gotta get it. So hopefully, okay, can you see this? Yeah, you can see it. Of course you can. -1x minus 1x. -2y is less than or equal to -1x plus 2. All right, now I'm dividing by a -2. It's go time for switching this thing. And now we have a +1/2x because it's a negative over a negative 2 divided by negative 2 is minus 1. So this thing's going to start at negative 1 on the y-axis. And you go up 2, right, up 1, right 2. It's not perfect. Okay, so we're going above the line I just drew. Above the line I just drew. I don't know what color to use. Can we see through this color? It's above this. Kind of. All right, so this is above that line. All right, here's the solution. It's where the magenta yellow color intersects with this teal turquoise. I'm not great with colors. I'm not sure exactly what it is. There it is. So it's not always like a triangular region in these situations, but in this case it is. So that region right there represents the shared shaded solution. All right, below that is another, just an interesting question that's asked. And what they do is they give you a set of ordered pairs and ask you, hey, which of the following ordered pairs are solutions to the system? There's two approaches. The first approach is to not graph anything at all. You take both equations and you plug in this for the x, this for the y. 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 And let me show you how that works. Maybe I'll do that over here. Yeah. So what I do is I say, hey, plug it into the first, the top one. Is 0 greater than or equal to 2 minus 2 times 1? You're just plugging it in. All right, is 0 greater than or equal to 2 minus 2? Is 0 greater than or equal to 0? Yes, because it is equal to itself. So the first inequality checks out. It has to check out with the bottom one as well. So you'd say, okay, does 0, is that less than negative 2 times 1 plus 4? Which is 0 is less than negative 2 plus 4? Is 0 less than 2? Sure is. So 1, 0 is one of our solutions. Yeah, and we can do that over and over and over again. You plug 2 in for x, negative 1 in for y, 2 in for x, negative 1 in for y, and then roll through that same procedure. I have a feeling a lot of you guys would probably just rather graph it and then check out the graph to see if the points are in there. So I'm going to show you that solution as well. So y is by itself already twice. That's good news. Don't have to do any algebra legwork. We just start at 2, go down 2, right 1. or up to left one, up to left one, down to right one, down to right one. Draw our line, bold. Shade above. So when I'm shading, I'm including the line right here. So every point that's on that line is magenta right now. Second one, I'm starting at 4 and also going down to right 1. Sorry, I gotta patch up what happened here. Come on now, come on. All of this. It's dashed. Oh my goodness. The shading is starting to fail. But it would be below. All right, so bottom line is, what's the shared shaded region here? It's supposed to be in between. But here's the deal. It's in between. It includes this line, but it doesn't include this line. Like there's a big difference between a dashed and a bold line in this situation. So when you look at 1, 0, it's on the line that's equal to, which is why it belongs in the solution set. When you check out 2, -1 over 2, down 1, yep, that's in the black dotted solution set. 1, 3. It is not in the black dotted solution set. And then 3, -2. So 3 down, 3 over. It's on the dashed line, so it's not in there either. All right. Whew. Okay, so those last 2 examples, kind of exhausting. They're just little extras that I wanted to show you guys so that you, I don't know, we're given the opportunity for a little challenge. Okay, 1.12 is complete. Thank you so much for watching. Thank you for your patience as you work through these mathematics. Yeah. I'll stop talking now. See ya.